Hi, my name is Yvette Ariela Nunez. I'm a third-year graduate student at the University of Georgia, currently working in the Ted Ross Laboratory studying avian influenza viruses. I was born in Sun Valley, California to two immigrant parents, and I'm a first-generation American. Being raised by two immigrant parents has impacted my life greatly in my career choices and my education pursuits. I've always been motivated to be successful and to make something of my life, and since I was a little girl, I've always been interested in science. In high school, I found my first love, biology, and after high school, I went to Cal State Northridge and got a bachelor's degree in cellular and molecular biology. Shortly after that, I joined the University of Vermont, where I graduated with a master's in pathology, and in 2015, I joined the University of Georgia, where I joined the Ted Ross Laboratory and study influenza viruses. My project involves the development of a universal avian influenza vaccine. Avian influenza, better known as the bird flu, infects wild and domestic bird populations and has catastrophic results on the poultry industry. Although this virus does not primarily infect humans, it can spill over into the human population and cause severe disease and often leads to death. Because this virus mutates so easily, scientists and government officials are concerned that this virus will evolve and become better suited for human hosts, starting a deadly pandemic. There are vaccines that are available in such case an event would occur, but the current vaccine is based only on one strain of virus that may not protect people from all the new circulating strains that are out there. This is where I come in. My project involves the generation of a computationally optimized broadly reactive antigen, also known as a COBRA vaccine, which will hopefully protect people from infection from all different types of avian influenza viruses. I use a computational approach that uses hundreds to thousands of avian influenza sequences and combines them in such a way that the vaccine contains features from multiple viruses in a kind of mosaic pattern. We base this vaccine using the HA or hemagglutinin molecule, which is located on the surface of the virus. COBRA vaccines are able to pick up sites from multiple types of avian viruses, so that if you get infected with any one of these subclades of viruses, you will still be protected. I believe that my research will help advance the field because I not only create avian influenza vaccines, but I also study why they work so well. This helps the field of influenza study because it gives us an insight on what features of the HA-based vaccine needs to have in order for it to be successful. This helps us understand what kinds of sites located on these molecules are most protective and what sites are not as important, so we have a better understanding of what makes avian influenza vaccines effective. Avian influenza viruses are never going away. They circulate in the wild bird population and often spill over into the domestic poultry population. As you may know, Georgia is the #1 producer of broilers and poultry in the United States. And if an avian influenza virus outbreak happens here, as it did in 2015, the results on our economy will be devastating. And we're also putting farm workers at risk at contracting a deadly disease. So developing a universal avian influenza vaccine is essential to protect our population and save lives. Getting the ARCS Foundation Award would help me immensely with my career. Along with its prestigious affiliation, the award will help me attend scientific conferences where I can share my data with other scientists and create a professional network to help me understand my field. The award can also help me publish in scientific journals and can defer the cost of laboratory equipment and supplies. Thank you for considering me for the ARCS Foundation Award and taking time to get to know me. Thanks.